The 150 kilogram carriage has an initial velocity of 3 meters per second down the incline at A. When a constant force of 550 Newton is applied to the hoisting cable as shown, calculate the velocity of the carriage when it reaches B. So this is the figure for the given problem. So here, the crate or the carriage has an initial velocity of 3 meters per second down the incline. So this will be your VA. Then a constant force of 550 Newton is applied to the hoisting cable. So if we cut this, so the force experienced by each cable is equal to your tension of 550 Newton. So we have here T and this one is T, while the mass is 150 kilograms. So your weight acts perpendicular to the ground. Weight is equal to mass times gravity, or 150 times 9.81, and that is equal to 150 times 9.81. So we have 1,471.5 Newton. So this is your angle theta. Now the slope, the ratio of the slope is given. We have 5, 12, 13. So in order to solve this problem and to simplify, let's make this a horizontal setup in our free body diagram. So here's our FBD, or the free body diagram. So your setup will look like this. To simplify, let's make it horizontal. So this is the carriage. So the weight acts here of 1,471.5 newtons. Now, the force experienced here is twice the tension. So the pulling force is 2T, or 2 times 550 equals 1,100 newtons. And your initial velocity VA is equal to 3 meters per second. So this is A, this is B. So what will be the velocity of this carriage when it reaches B? So your VB is unknown, and that is the required. So let us identify the other force, or the other forces. So if this is your weight on a diagonal direction, so it has an y component and x component. So this is your wx, this is your wy, and this one we also have here the normal force exerted by the ground. So this is your F sub n. Now let's proceed to the work energy equation. So the work energy equation is the resultant force is equal to the change in kinetic energy. So positive work minus negative work equals delta Ke. So let us identify the positive work and the negative work. So the first positive work is the work that is caused by the pulling force, the tension force 1,900 Newton. So we have here 2T times D minus, so the negative work is your Wx times the distance D, wherein your D here is 3 meters. So Wx times D equals 1/2 of the mass. So this will be m/2 times final velocity Vb minus initial velocity Va. Now, what is Wx? So your Wx is the x component of the weight, and that will be 1,471.5 multiplied by 5/13. So since this is your triangle, is 13, this is 5, and this is 12. So now we have Wx, we have 2T, we have the D, we have the mass, we have the velocity at A. So let's substitute. 2T is 1,100 multiplied by 3 minus 1,471.5 times 5/3 times the distance of, or over 13 times the distance of 3 meters equals 150/2 times the quantity of Vb squared minus, so since this is a negative velocity, so minus negative 3 squared, since this is going to the left or opposite of the motion. Now let us further simplify. So we have 1,100 times 3 minus 1,471.5 times 5 times 3/13 or plus 150 times 9 over 2 equals 150 over 2 times VB squared. So, we have one unknown VB, so your VB is equal to, so we have here 1,100 times 3 minus 1471.5 times 5 times 3 over 13 plus 150 times 9 over 2 equals divided by 150 divided by 150 over 2, and that is equal to 30.36. Then get the square root of the answer. So we have velocity at B is equal to 5.51 meters per second, and that gives the answer for the problem.